Okay. Well, welcome to Heat Pumps 101. This is a course to save the world. We're going to have to pay particular attention. There might well be an exam. This is, after all, a university. So, Katie, may I have the next slide? Katie, you there? Yeah, Katie, could I have the next slide? Yes. Climate change, human-caused climate change is real. The science is irrefutable. Severe, even deadly weather is increasing and will continue to get worse. The cause is greenhouse gases in the atmosphere, which change weather patterns. Greenhouse gases are emitted by burning carbon, oil, natural gas, and the other fossil fuels that have powered our lifestyle and civilization. Next slide, please. What can we do about it? Next slide. Next slide, Katie. Oops, one too many. We can move away from carbon, but to what? The clear alternative is towards more electricity. Photovoltaics, solar, and wind are growing rapidly to replace coal and natural gas generation. In Alberta, of course, your oil, coal, and natural gas, you're moving away from coal next year, I believe. Electric vehicles are the fastest growing segment in transportation, but space heating is a major need. Next slide. This is really key. Space heating is a major need in Canada, and resistance electric is expensive. 82% of energy used in Canadian homes is for space heating and cooling and heating water, according to the latest federal data. Remember this. Okay, next slide. There is a carbon-free heating and cooling technology that is at least 3 times as efficient as resistance electric and of burning fossil fuels. Ground-coupled heat pumps. Major utilities call it the most efficient heating and cooling technology available. Electricity is a prime energy and is more expensive than fossil fuels. But there's always a payback when these units can be more than 5 times as efficient in the coldest conditions. In warmer weather, the heat pump is even more efficient than a standard air conditioner. COPs of 60 have been recorded. And remember, life cycle cost. It might be a little more expensive to put in, but there'll always be a payback. Okay, next slide, please. All the Earth's energy comes from the sun. About half this enormous flow that reaches Earth is reflected back or absorbed by our atmosphere. But the remaining half is absorbed by the oceans and landmass, converted to thermal energy and re-radiated into space. Only 1/5000th of the incoming radiant energy is transformed by photosynthesis into plants that provide the irreplaceable foundation of all of our lives. Thus, the Earth is the best solar collector, and with geothermal energy from the center of the Earth, the best storage system. how can we use this free energy to our advantage? The best way I know is with heat pumps coupled to the ground. And next slide. The heat pump is a very simple device. As the name implies, it simply moves heat. No combustion, no carbon emissions involved. Your refrigerator is a one-way heat pump. The heat is moved from inside, thus cooling it, to the radiant grill on the back, which heats your kitchen. A ground source heat pump, or ground coupled heat pump, moves heat from the ground into the building and raises its temperature. The ground collector is usually buried polyethylene pipe filled with water and antifreeze, or well water, which circulates through the heat pump. The compressor, which is located safely inside the building, converts this energy into usable hot air or hot water very efficiently. Cooling is done by reversing the energy flow. Next slide. They can be installed anywhere and use, excuse me, they're more efficient than unlike they can be installed anywhere, unlike geothermal generation, and operate all the time, unlike wind and solar. The next slide. Katie, next slide. The closed loop ground collector is configured horizontally or vertically. Since trenching is less expensive than drilling, horizontal is preferred if a 2-meter deep trench can be extended 7.5 meters or more per kilowatt of heat pump size. Vertical collectors can be installed anywhere a drill rig can operate. The 2 pipes connected by a U-tube at the bottom are installed at each hole. Horizontal pipes connected heat pump to the ground collector. Our featured presentation will be using this configuration. Next slide. We just talked about vertical. And next slide. Closed loop can store energy for months when heating the building in winter. The ground is cooled, even frozen, giving the advantage of latent heat. When switching to summer cooling, the cold or still frozen ground is heated, making the heat pump more efficient. At the end of the cooling season, the ground has been heated, which makes heating more efficient. Closed loop ground lake loops can also be used. Well water, that's the open loop system, can be the most economic. They use existing wells and plumbing, requiring only a discharge well over 20 meters from the first into the same aquifer. The return well requires a higher capacity since it's more difficult to inject water than to withdraw it. Ground coupled heat pumps are configured to good condition air or water. Many units have de-superheaters, which provide about 70% of the hot water in most homes. And in fact, in our home, I've turned off our hot water tank, and all of our hot water will be supplied during the winter by the desuperheater. This is significant since heating water uses about 20% of the space conditioning energy. Water-to-water units can heat radiant floors and even swimming pools very efficiently. Codes and standards are based upon sound experience and should be followed. Proper sizing and installation are critical and should be performed by trained professionals. Using federal government numbers, next slide. Using federal government numbers, the average Canadian home installing a heat pump, a ground-coupled heat pump, would become net zero. Remember that 82% of the energy is now being supplied by the heat pump. It becomes part of the climate change solution. It saves more energy than it uses, and the CO2 emissions can be eliminated. It has made the house renewable. Ground-coupled heat pumps are more efficient than air source heat pumps and air conditioners because the ground is warmer than the air in the winter and cooler in the summer. 5 meters down, the temperature is constant at the annual average temperature of the surface. A heat pump is a single unit instead of a furnace and air conditioner and can be manufactured at lower cost. Basically, a heat pump is an air conditioner with a reversing valve. Most of the components are the same. So it stands to reason that one unit will be more economic to manufacture than two. The installation of the ground collector is more expensive, but using wells, groundwater, or innovations like the National Research Council of Canada's SEC spiral, or multi-installations, in other words, a subdivision, all dug at the same time as the basements, have resulted in lowest first cost installation. And remember, there's life cycle cost. It will always be the lowest cost life cycle. Most of the best economics have come from, some of the best economics, sorry, have come from Northern Canada, where buildings on permafrost are built on, excuse me, heat pump ground collectors instead of expensive gravel berms to keep the buildings from melting into the permafrost, sinking and breaking up. The buildings are heated by keeping the permafrost frozen. Win-win. There's so many successful installations and environmentally sound examples, but here are a few of them. Queen's Quay in Toronto, Museum of History of History in Ottawa, Purdy's Wharf in Halifax, and the cruise ship terminal in Vancouver. And then next slide. Here are some opportunities for Alberta. Oil drillers can find new work. Oil and gas drillers. Water wells and abandoned oil wells can be used for heating and cooling. A new industry can provide manufacturing and installation jobs. Heat pumps can be easily manufactured in Alberta. The prototype of the highest efficiency unit in the world for over 10 years was built in a Canadian garage for less than $1,000. And next slide. The takeaway is that if you put in a ground coupled heat pump, the building becomes net zero. And with kudos to Bill Eggerston, Net Zero Plus. And slide. And now it's my pleasure to turn over to the featured project of the seminar, the Blatchford Housing for 30,000 in downtown Edmonton. This is world class. Of particular note is the financing and integration of best practices in energy conservation, district heating, and heat pumps. Over to the project manager, Dr. Felske, with congratulations and many thanks. Christian, to you.
Thank you, Cam. Thanks for this introduction and I think for this great overview about heat pumps. I will try to build on this presentation, but focus on a project here in Edmonton, as Cam alluded to. My name, Christian Felske, as I said, I work for the city of Edmonton, and I have the pleasure for 5 or 6 years now to have been working on the Blatchford project. And I'll speak in this slideshow a little bit about the Blatchford project, but also focus on the utility company I'm managing, Blatchford Renewable Energy, trying to provide 100% renewable energy into a carbon neutral development that Blatchford hopefully will be. For those of you who live in Edmonton, you've probably heard about Blatchford. It's about 10, 12 years. It was a very controversial topic in local politics, maybe regional politics. It represents a once in a lifetime opportunity. What you see on the left side of the left picture here, to convert an old municipal airport into one of the most sustainable developments or communities in Alberta or Canada. Cam was mentioning when City Council decided to close the municipal airport, they also put in place a rather ambitious vision for the land. Blatchford will be home to up to 30,000 Edmontonians living, working, and learning in a sustainable community that uses 100% renewable energy, is carbon neutral, significantly reduces its ecological footprint, and empowers residents to pursue a range of sustainable lifestyle choices. So you see that the Blatchford project, not only from the energy side, has sustainability all written over it, in the way people are living in the community, in the way people are moving in and from the community, but also in the way the residents and businesses in Blatchford will receive their energy in this community. I gotta have a little bit of a few videos to show. This first one really establishes the community and provides an opportunity what's the city's goal here is. So I will play this.
How do we want to live? How do we create community during a time of change? How do we build places for the people who would call them home? How do we take care of our neighbors? How do we think about what a neighborhood should be? How do we get around them, to and from them? How do we power our lives when power has been a part of the problem? How do we remember our past while respecting our future? How do we make sure it's accessible to everyone, socially, physically, economically? How do we want to live? We're building a neighborhood where we can find the answers. Renewable infrastructure, sustainable design, historic, central, Blatchford. Urban design that's never been tried in Canada. A community that's never been tried like this anywhere, in the heart of Edmonton.
So that was a nice introduction to the Blatchford development. For those of you who are from Edmonton, live in Edmonton, you're probably very aware, you're driven by it once or twice. Some things to consider in terms of implementing this ambitious vision is the city's role in the project. And the city owns the old airport land and is also acting here in this development as the developer of the community, meaning we're preparing the infrastructure and for builders to come in, builders who share the same vision than we have on Blatchford, to build their homes and eventually sell their homes to people who also have the same vision and who want to live in a very close to downtown community. There's obviously very many aspects we need to take in consideration when building Blatchford: the site context, the climate, as Ken was alluding to, the opportunity here for some of the most emerging sustainable technologies in the world, I would say, but also doing this in a fiscal responsive or responsible, nimble way. Always an eye open for looking at what other technologies are on the horizon to address the threat of climate change. A bit overview of Blatchford. There are, I would say, 5 distinct phases in Blatchford. So Blatchford West and Blatchford East are the areas where most of the residential, some institutional development will take place. Blatchford Market in the south tip of the site, close to where Kingsway and Prince Elizabeth Avenue are meeting, probably the more active part of the development, more office, more commercial development anticipated there. On the east side, we border to Nate. Nate is also a larger landowner in Blatchford. Nate wants to extend their current campus into Blatchford and also have subscribed to the vision Blatchford has. All of this centered through a civic plaza, which is sort of like the size of Winston Churchill Square downtown Edmonton at the City Hall, and centered with a large park in the middle of the development, the Blatchford Park, with 2 stormwater ponds. And we talk about the stormwater ponds when we talking about some of the installation of the geo-exchange wells we have on site. Many aspects of sustainability, as I mentioned, the way we manage our water, stormwater pond, low impact developments, water reuse as best as possible, but also sustainable aspects in the way of transportation. On the slide to the left, the current LRT system will be extended into Blatchford. There will be 2 stations, and these stations are rendered here on the left side, will extend the LRT, and will also provide some opportunity for additional solar PV at the stations to offset some of the energy required to run the trains. Why are we looking at heating and cooling and buildings in general? And Cam had some nice numbers, and I can also echo these numbers when we look at the total Edmonton greenhouse gas emissions from the community of Edmonton. Emissions from residential and commercial buildings accrue to over 40% of the total greenhouse gas emissions in Edmonton. So if we can make a dent in that sector, reducing the almost 6 million tons of CO2 equivalent, which are currently released from Edmonton homes and buildings, then we can make a significant effort into reducing climate change and address the climate crisis. Now, when we talked about energy in Blatchford, we always saw this as a 3-pronged approach, starting from the building perspective, conservation. Builders who come to Blatchford have requirements to build to a very high energy efficiency standards, better than the current code, as an example. So very high efficient buildings, high performing buildings are going to be built in Blatchford right now. That also means that these buildings are actually requiring less heating than the traditional building in Edmonton, because they're built to a better standard. It also results into somewhat higher cooling load, as Cam also mentioned. The better the building, the more cooling it will need when it gets to more extreme weather events, like we had the last 2 summers here in Edmonton, where temperature reaches 30+ degrees C. The second pillar is about efficiency, and this is where an ambient district energy sharing system comes into play, which is an ambient temperature system, which works with extremely efficient heat pumps in our central district energy plant, but also in the homes which are going to be built in Edmonton, which are built in Blatchford and will be built. So these buildings, to put it simple, won't have a natural gas furnace or a natural gas hot water heater in their buildings. Instead, they have 2 heat pump systems which provide space heating and cooling, but also a heat pump for the domestic hot water provision for the building. So the beauty of that is that heating and cooling will be developed or will be delivered by the same system. So instead of having a furnace or an air conditioner, both of this can be delivered from the same system and the same loop. Renewables forms the third pillar, and this is provided initially through a geo-exchange field, which I'll provide some pictures and some slides in a second here. The ability to get the heat from the ground in the winter when we need it, but also put the heat back into the ground in the summer when the system runs more like a cooling loop. So it's an extreme great opportunity to use the heat and the energy stored in the ground for heating and cooling purposes all year long. Some other projects we're thinking about, we're in the early phases of design, is to harness some of the heat of the underlying sewer system. It's a tremendous amount of energy within the sewer system, and obviously the opportunity for solar PV is something we're looking very careful here in Blatchford as well. Another video, and this video explains in more details, better than I can, what district energy sharing is and how heat pump play a role in this.
Building one of the world's largest sustainable communities doesn't happen without a clear vision and commitment. Blatchford is being built from the ground up as a model for green, renewable, carbon-neutral planning and design. Blatchford's energy strategy focuses on 3 pillars: energy conservation through high-performance green buildings, energy efficiency driven by an innovative district energy sharing system, and the incorporation of renewable energy sources like geo-exchange, sewer heat recovery, and solar PV. Blatchford is supported by a district energy sharing system, which is a centralized system built in the community that distributes and shares heating and cooling energy throughout the neighborhood. Sharing energy between buildings can reduce overall energy consumption by 15 to 20% compared to traditional energy systems. The first stage of the district energy sharing system uses a geo-exchange field as its main renewable energy source. Blatchford's first geo-exchange field is located under one of our stormwater ponds and will support the first stages of residential development. Geo-exchange involves a system of underground boreholes that transfer heat to and from the ground, pulling the natural heat from the earth in the wintertime and transferring excess heat from buildings back into the ground in the summer. The first energy center will be the heart of the initial stage of Blatchford's district energy sharing system. Using heat pump technology, the energy center transfers energy from the geo-exchange field to homes and back again through a network of water pipes beneath the Blatchford roadways. Instead of a typical furnace or boiler system, each building will have a heat pump-based energy transfer station, which extracts the thermal energy from the district energy sharing system and upgrades it for the building's heating, cooling, and domestic hot water needs. Heat pumps upgrade energy more efficiently than a typical furnace, reducing Blatchford's greenhouse gas emissions compared to a business-as-usual community. By using a flexible approach and taking advantage of some of the most innovative and efficient technologies of today, Blatchford will help establish Edmonton as a leader in community-led renewable energy.
I should say there was a website mentioned, blatchfordutility.ca. All of these videos are on there, so if for some reason you didn't get them, you can look at them and get a little bit more explanation about what they are and what the system does. So, just moving on. So right now, we're in the early stages of community development. In terms of the district energy sharing system, we built the first phase. The first phase is based on geo-exchange under a stormwater pond in the community which is part of the Central Park. So there are two loops, the ground loop, as we call it. There are about 570 wells drilled about 150 meters deep, 6 meters apart, carrying a fluid to the Energy Center 1, where we have a very, very efficient heat pump located, which basically transfers that energy, as Cam described it, to an ambient temperature regime between 10 and 20 degrees, and basically transfers that energy in a second loop, like the district energy loop, towards the buildings and homes in Blatchford. So there's a supply and a return line. The buildings itself, as I mentioned, have then heat pumps, which are then utilizing these heat pumps also in a very efficient way to provide the necessary heating and cooling need in the buildings. The beauty of this system is very efficient, as we hear from Cam. Heat pumps are probably the most efficient mechanical equipment to transfer energy. So we're done combusting things for energy. We're transferring energy both ways, from hot to cold and from cold to hot. It's a very efficient way. The fact that many buildings here are on a loop is an extreme wonderful opportunity to also share energy between buildings. So there will be times during the year when a building is more in a cooling mode and brings back heat to the loop, and that heat can be picked up by another building who is in a heating regime. So there's a tremendous opportunity to just share energy between buildings and not rely on energy generation and reduce energy generation by about 15 to 20%. Some pictures of the construction of phase 1. On the left side, you see 4 drill rigs. Cam mentioned the abundance of drill rigs in Alberta, the opportunity for many trades to come and build these renewable systems. As I mentioned, we drilled 570 wells, about 150 meters deep. So that's about the height of the Epcot Tower in downtown Edmonton. So it goes significantly deep. It's still considered shallow, and temperatures in about 150 meters deep range around 8 degrees C. So that's sort of like the temperature regime we find in the geo field. On the right side, you see that this ball field was built under a stormwater pond for the development. So it's less sexy than solar installation, because once you build it, you don't see it anymore. It's still working very efficiently under our feet. The distribution piping, and you see a couple of pictures here. As I said, no energy is lost in this system. There's a supply and a return line where energy is supplied from the energy center to the homes and back to the energy center, and then either into the ground loop or just used in the buildings. So we are building this district energy piping, this distribution piping as part of the regular utility infrastructure in Blatchford. So we're building it alongside sewer, water lines, power lines, and other utility lines which are required for any regular development. Energy Center 1, a very beautiful building. It's a very beautiful mechanical room, really, that's what it is. The reason it's built with this architectural design is that it will be a center point on the central square in Blatchford. I mentioned when I laid out the development of the site that it all centers in a big square, and that will be representing the new way of energy to be provided in Blatchford. On the right side, you actually see a heat pump. This is a large industrial heat pump. The biggest one, I believe, in Edmonton we have right now. It's 1 megawatt of thermal energy. It has a COP of 10. So a very, very efficient heat pump, a very, very powerful heat pump. And this heat pump is right now supplying the energy for the first stages of development. We are in the process also to extend Energy Center 1 to basically build 2 or to install 2 or 3 more heat pumps, as we need more heat pumps as the development and the demand growth in the utility and in the development. So one last video explaining in detail how a heat pump works and how it works in combination with the district energy system.
Did you know that heating and cooling our homes is a major source of greenhouse gas emissions? To reduce our carbon footprint and create a sustainable future, we need to rethink how we heat and cool our homes. Instead of using furnaces and air conditioners that rely on burning fossil fuels, Blatchford buildings will use heat pumps that rely on transferring energy. Heat pumps are the most efficient mechanical system for heating and cooling. A home heat pump produces 400% more energy than the electricity it consumes. To obtain 40 watt-hours of heat energy, only 10 watt-hours of electricity are used. In comparison, to obtain 40 watt-hours of heat energy with a traditional high-efficiency furnace, 44 watt-hours of natural gas are needed. Heat pumps work by leveraging a basic principle of physics. Heat moves from hot to cold. A heat pump has both a warm side and a cold side, and uses a refrigeration circuit to move energy between the two sides. In heating mode, a refrigerant vapor is compressed, causing its temperature to rise. When it's hot enough, the vapor passes through a heat exchanger coil. A fan blows air across this warm coil, sending heat into the home. The cooled refrigerant then continues on to an expansion valve. As it goes through the valve, its pressure drops, the gas expands, and it gets colder. But why are we cooling the refrigerant when we're trying to heat? The answer goes back to the basic principle of physics mentioned earlier. Heat moves from hot to cold. By cooling the refrigerant, it can now take more energy from the warmer water that is in the district energy sharing system's pipes. Once the refrigerant has been rewarmed, the loop starts again. The cool part about heat pumps is that they're reversible. They can also cool your home. In cooling mode, the circuit is reversed. Cold air is blown into your home for air conditioning, and the hot refrigerant is cooled by the district energy sharing system. The excess heat energy is removed from the home and transferred back into the district energy piping to be reused for heating other buildings. By using heat pump technology and a district energy sharing system, Blatchford Renewable Energy is creating a more sustainable future.
So very nice, almost corporate videos, but explaining the significant advantages and the quality of heat pump technology. So I talked a little bit about what the future holds for Blatchford. The next heat source we want to tap into is the sewer heat. As I mentioned before, there are 2 significant sewer lines under the development, and the opportunity to utilize the heat, and not only the heat, of this combined sewer line to transfer that heat into the district energy sharing system. So basically into the full network of piping we have. The beauty of that is that the temperature in the sewage is almost at the same temperature or in the same temperature range we're operating the district energy sharing in. So between the 10 and 20 degrees C range. So that simply put, we'll need a heat exchanger, but also potentially another heat pump for extra energy, depending on how the development goes and what energy requirements are there. We do have solar with heating and cooling. We're tapping about 75% of the energy of a energy input into an average Edmonton home. We need to tackle the electricity portion as well. We're thinking about, we have some solar installation. A lot of the builders who come to Blatchford are actually installing solar, and if they're not installed by the builders, actually a lot of residents are going ahead and install solar on their roofs to really make their home fully net zero carbon. So overall, at the full build out, what does this mean in terms of carbon? So we see a reduction from the emission of a typical community by about 75%, and that results into an absolute reduction of about 30,000 tons of CO2 annually, which is quite significant. And as I said, concerning the piece that about 40% or more than 40% of our greenhouse gas emissions are coming from buildings, residential and commercial these days, these type of technology can really make a big dent into our climate effort. We're at the beginning of Blatchford, as you probably heard. We're building the first stage. But we're also planning the next stages, right? We're providing a utility system people rely on. It becomes a life-threatening situation when there's no heat to a home. So we have to focus on reliability, operational excellence, but also on the fact that we want to grow, and we're growing with the development. We're currently in stage 1, but we're also already building the next few stages for the district energy system. A few words on how we're governing this and how the city is governing it. Basically, to make sure and to ensure that the vision for Blatchford is intact and is upheld throughout the building process and the development process. Our city council has put in place a municipal-owned utility company, which is titled Blatchford Renewable Energy, which is what I manage. That utility provides heating, cooling, and hot water services to the homes and businesses and schools in the Blatchford community. So as with any utility, we do have to do our financial forecasting, our capital investment needs, our operating needs, together with provisions about rates, how much people are paying for their energy. Because one thing we need to be very clear on, that this is not the cheapest way to provide energy to the homes in Canada and in Alberta, particularly. If it would be the cheapest way, the cheapest technology, I would argue that everybody would do it, but not everybody is doing it. The city is doing it because it has a certain vision for Blatchford. It necessarily provides a next step in the overall climate emergency question, and we hope that some of the ideas we're developing and proving in Blatchford right now, we're hoping that some of these ideas are going to make it outside of Blatchford into other developments in Edmonton, Alberta, and hopefully Canada. As with any utility, we do have governing pieces in it. We have a utility bylaw, which basically mandates the connection of people who come to Blatchford to the utility, unless they can show that they can be net zero carbon right away. So there's an exception clause to this. This bylaw also regulates how we are connecting, what powers the utility has in terms of connecting a building or not connecting a building, what is the utility's responsibility versus what is the building owner's responsibility, and what our rates are and what our fees are and what we charge for the energy, because we're not doing this for the faint of heart. We also incur costs, and these costs have to be coming back from our customers, which we're providing energy to. We also have a fiscal policy in Blatchford. I'm not intending you shouldn't read these documents from this slide. They're way too small. I'm just using it as an example. And one of the critical things, what our council has said, that somebody within Blatchford should not pay more for their utility bills and their maintenance costs than the average home in Edmonton outside of the Blatchford area. That provides some security for the customers, for the builders and the clients, the customers in Blatchford, but also provides a limit on what we can charge for our rates compared to our costs. So by all means, the fiscal management of the utility is a challenge. We're talking constantly with the provincial and the federal government for funds to promote the climate file nationally, and our mayor and our councillors are very heavily involved in promoting Edmonton, all of Edmonton's effort on the climate file altogether. So we're planning for a city of the future. Blatchford is a greenfield development, a very central greenfield development, an incredible opportunity to do things right from the ground up. But we also know that not all the developments are like that. There's a lot of existing buildings which were built in Edmonton when times were different. Climate considerations weren't at the top of the urgency, and just were built with different technologies. But what we're hoping with Blatchford is to achieve is that, like I said, that some of the ideas around how people move, in what density people live, and how people receive their energy and promote a sustainable lifestyle can swap over to other areas of the city. So with that, I thank you. Thank you to Concordia for the invite. Thanks for Cam for providing the first part of the lecture, and maybe Cam wants to do the test right now on heat pumps. But I'm also open to questions or comments. Happy to hear some of them. So thank you very much.
Yes, thank you, Christian. Someone actually asked a question in the chat, so I'll just read it here. It says, to what low temperature does the geothermal suffice before needing a backup heating source? Will that be supplied by sewer energy and optional solar? That was from Jim. Thank you, Jim.
So if I understand this question correctly, is we can operate our heat pumps year-round at temperature up to minus 30, minus 40. We don't need an additional source for the heat pump. The overall system, and I'm talking about the home, the overall district energy system is not built to have the peaking covered by renewable energy sources. So we do have peaking boilers in our long-term build-out, which covers peaking events. The reason for that was the capital investment would have been too high. There would also be a limitation on the amount of ground heat we would have to really provide peak energy. So we are getting not 100% renewable overall when we're looking at this year-round. At full build-out, anticipation is that we're probably around 98, 99% renewables, with some peaking coming from peaking boilers, which we have investigated to utilize some renewable natural gas or some other alternative fuels if they become green fuels, if they become available in the future.
Awesome. Is there anyone else? Oh, go ahead, Cam.
Could I just add, I'm sitting in a home that is actually in Canada, suburb of Ottawa. we have had a heat pump for 35 years, and the backup electricity, the little toaster, the resistance electric, has never been on. It's there if the heat pump fails, but as I say, it's never been on.
And there are no backup units, no heating units required for a ground source coupled heat pump in Blatchford. If you're looking at air source, which is another type of heat pump, these heat pumps typically in Alberta have the same backup heating Cam was talking about. This is connected to the ground loop, and we achieve our COP up to much lower temperature than compared to an air source heat pump in Alberta.
Yeah, the utility ramifications of having an air source are that when you're peaking in the winter, when everybody's got their electrical loads, that's when the air source cannot meet the demand. And it's an added burden to the utility, and a considerable one.
All right, is there any other questions from anyone else? You can, oh, Bill, go ahead.
Christian, an idea you might want to consider, I'm involved with a group called Net Zero Plus Canada, and we're getting ready to launch a national campaign. It's going to take me about 60 seconds to do the elevator pitch so that everybody understands what I'm talking about. But the first point is that energy can use standard nomenclature, whether it's barrels of oil, tons of coal, whatever. You can talk in SI measurements of joules. You can also convert everything into kilowatt hours. As we say, if you're going to electrify the world, let's speak in electric. Second point is that heat pumps are totally dispatchable. Third point is that heat pumps are not really energy efficient. The building requires X amount of heat. How you get it, what you get, how, whatever, you are still consuming or needing or having to have X amount of heat. The key point that you might want to consider is that heat pumps produce energy. First law of thermodynamics says you cannot create energy. Heat pumps do not create energy, they produce it. Your visual going through the condensing valve and through the compressor and all through that shows very well that it's not a simple transfer. You're not taking the handful of heat and throwing it into the building. You are making it go through a process. We consider that a form of production, in the same way a wind turbine and a solar panel produce electricity or generate whatever verb you want to use, but a heat pump produces. The average home's thermal load for heating, space cooling, and water heating is 30,000 kilowatt hours a year. If you were to actually, and 100% of that comes from the ground, you have to pay a penalty for the compressor and all of the performance energy. But if each house in Blatchford aggregated 30,000 kilowatt hours per year, nationwide, it's 350 billion kilowatt hours a year that Canada's homes need. If they were produced or supplied by heat pumps, that would mean heat pumps produce 350 billion kilowatt hours a year. What is the implication there in terms of marketing, in terms of playing the game with net zero, which 50% of which is BS right now? People are not putting in figures. And I think the heat pump industry is underselling itself if we don't take credit for the fact that we are producing, and I underscore the verb producing, energy. Something that Blatchford, you could quantify, measure, however you want to do it, that Blatchford produces kilowatt hours per year, and you're only needing a third of that to actually keep the houses warm.
Thanks, Bill. I'm interested. Maybe we should talk offline of this. I cannot say that I'm an expert in how heat pumps work, and maybe I'm not using the right terminology. I appreciate the appreciation you show. This was like a development process, or looking at what is the best fit here and how do we start for the vision we had for the land, right? And we started with heating and cooling. It seems to me if I look at the global situation and some of the regulation which are coming up now in Europe, for example, in terms of the shortage of natural gas, it seems we're at a very critical breaking point in terms of where we're going to get the heat for our buildings. And it seems to me that the promise of heat pump is only going to go up. The efficiency is only going to go up. So I'm happy to show to everyone, especially our council, the benefit of what we're building here in Blatchford, right? And it is, however, also we need to look at also it from the reality of planning a utility, and a reality to also deal with the building industry, right? There's a tremendous amount of education which is still needed for certain builders in the city to understand what we're doing in Blatchford, to comply with it. There are builders who are very much aware of what a heat pump does and have built these systems many times before. But I sure hope that just the pure production of heat pumps for Blatchford will help the industry, will help hopefully people like you and the center at Concordia to really look at it at one option. I'm probably not saying that this is the one egg we should all put the one basket we should put all our eggs in. There's many ways to get there. There's no one silver bullet as far as I know. We thought, or we think, this is the best way to approach the Blatchford vision, and I think we're actually very confident. And in terms of operation, it's quite positive, right? We've been through 2 years of operation now, with people living in buildings, going through cold winters and hot summers, and they're very, very happy with their system they're provided. So thanks for that. And Bill, hopefully we can reach out and you can tell me more about your initiatives and how we can support each other. Thanks.
All right, we just have one last question here. David asked, in terms of regulations, is the province trying to regulate heat like electricity or gas?
So regulation is a very important topic in all of this, because like when we started, the only reason we as a city could embark on a project is because we are under the Municipal Government Act, and under the Municipal Government Act, the city has the provision to put in place a public utility like we're doing in Blatchford. There is no actual regulation of district heating systems in Alberta as we speak. There are a few systems. We have systems at both universities in Calgary and in Edmonton. There's a downtown system in Calgary, which originally was owned by the city of Calgary and NMAX. Now this system has changed owners just about a year ago, and it's the first privately owned district energy utility in Alberta. So the way utilities are regulated is through the Alberta Utilities Commission. And we hope actually that the city is not the only one who is interested in building these type of utility system. We want to encourage private developers, private utilities companies, or private enterprises to come and build these systems, because the city cannot stem all of this system. We can lead, we can facilitate, but we sure over time hope that the opportunity is shared with industry and the costs are shared with energy. So in terms of regulation, that would mean that at some point we hope there is no, there's no current regulation, David. We hope that the development of more private system will provide that regulatory framework for people to come in. In BC, for example, the BCUC, the BC Utilities Commission, has a regulation for district heating utilities, and there are far more district energy utilities than in Alberta, in BC, in Vancouver, and in Vancouver Island. But in terms of Alberta, we're not there yet, but that's certainly something we want as a city to see.
All right, I think that is time for us. So I just want to thank everyone for joining us today. Thank you, Christian and Cam, for sharing with us these wonderful presentations. If you have any more questions, please feel free to email mcneilcare@concordia.ab.ca. We will be sharing the recording of this call on the QTV website, so please feel free to share it with anyone that you know. And thank you, everyone. Have a wonderful afternoon.